Alright, let's mathematize. Today we'll be looking at the equation of a straight line, and we'll talk about three forms of writing the equation of a straight line. Now, before I move forward, let me just state some facts. For you to call an equation a straight line, there are two things you must check out for. You must check out for the power of the variables of x and y. If the power of the variable is 2, it is no longer a straight line, it becomes a curve. If the power of this other variable is 2, it is no longer a straight line, it is a curve. But when the power of x and y are 1, you call that line a straight line. Another thing, for all straight lines, their gradient is a constant value. But for curves, their gradient changes from different points. But for all straight lines, their gradient is a constant value. Now, I won't talk much about knowing a straight line, but let me just give you the general form for writing a straight line. The first form of writing the straight line is y equals to mx plus c. Now, you may want to ask, what's this m and what's this c? Now, the m is giving us the gradient of the line, the gradient or the slope. N is called the gradient of the straight line, or you call it slope. Now, if you consider this straight line, let's consider this straight line, and let's choose a point, and let's say this point is x1, y1, and let's choose another point and call it x2, y2. And I will draw a triangle like this to show you what I mean by gradient. Now, if here is x1 and this is x2, it implies that the distance between these 2 points is just x2 minus x1. If this point is y2 and this point is y1, it implies that the distance from this point and this point is actually y2 minus y1. Now, gradient n is actually change in y, which is this, y2 minus y1, all over the change in x, which is just x2 minus x1. Now, also, if you observe this triangle, there is an angle to the horizontal. There is an angle theta to the horizontal. Look at that angle. Tan theta, from trigonometry, we know that tan theta is actually opposite over adjacent. And what's the opposite? Change in y over adjacent, which is change in x. So we can therefore say that gradient is also tan theta, so long that theta is to the horizontal. So we can say where m, which is gradient, is equal to slope or tan theta, or change in y over change in x. Now let's define c. Let's define c. C, by observation, you will be confused already. I know some of you are confused what C is. C is actually the intercept on y-axis. Now let me explain what I mean by intercept. Look at this straight line. The intercept is the point where the line touches the x-axis or the y-axis. At the point where the line touches the x-axis, we say it's the intercept on the horizontal axis. At the point where the line touches the y-axis, we call it the intercept on y-axis. Now, how do you get the intercept on either axis? To get the intercept on x-axis, if you observe, like, take it back to the origin, y becomes 0 for us to get the intercept on the x-axis. Then to get the intercept on the y-axis, x has to be 0. X has to be 0. Now, if x is 0, we'll have y is equal to m times 0 plus c. We'll have y is equal to 0 plus c, and y is equal to c. That's how we know that, yes, that this is intercept on y-axis. To get intercept on x-axis, y has to be 0. If y is equal to 0, we'll have 0 is equal to mx plus c. Mx, when we take c to the other side, it becomes negative, is equal to minus c. What's x? Minus c over m. This is actually the intercept on the x-axis. So whenever you are given a straight line of this form, just do this negative of this divided by this. We give the intercept on the x-axis. That's for the first form of writing the equation of a line. Do not forget, like this video. So let me talk about the second form of writing the equation of a line. The second form, I just want to derive it. I won't talk much. In deriving it, let me just state some facts. Minus c over m, intercept on x-axis, c, intercept on y-axis. Now, if we have y is equal to mx plus c, I want to make the x and y variables to stand on one side. I will have to take this mx to the other side such that I will have minus mx plus y is equal to c. If I divide both sides by c, I will be left with minus mx over c plus y over c is equal to 1. What do you observe about this c? Intercept on y-axis. Now look at, I want to manipulate this part which is minus m over c. For indices, you know that m over c or a over b can be written as 1 over b over a. So instead of me to write this as this, I can as well change it to 1 over minus c over m times x plus y over c equals 1. So I can say this is x all over minus c over m plus y over c is equal to 1. Now we just said that minus c over m is the intercept on x-axis and c is the intercept on y-axis. Observe carefully, intercept on y-axis is the net y, intercept on x-axis is the net x. So we can say net a equals minus c over m and b equals c. So we can just write the equation as x over a plus y over b equals 1. And this is the second form of writing the equation of a line, where a is intercept on x-axis and b is intercept on y-axis. So for this form, they hardly ask questions on this form, but look at the cases where they ask it. They will give you a graph, for example, and give you a point, let's say 1, and another point, let's say 2. Let's say 2, and they draw a graph that touches these 2 points. By observation, this intercept and this intercept, we can just simply write x over intercept on x-axis, which is just 1, plus y over intercept on y-axis, which is just 2, is equal to 1. And this is the equation of this line. Although there are other ways we can get the equation of this line, but for this method, we already know the intercept. Instead of us stressing ourselves, we can easily get the intercept on x and y-axis. We can solve for the equation of the line. So that will be all for this video. Our next video will talk more about the other forms of writing the equation of the line. But please do not forget, like this video, comment on this video, share this video, subscribe to my YouTube channel. See you later. I remain Almighty.